I'm Don MACHHOLZ, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 33 for the week of August 19th, 2020. The related website for this podcast is donmachholz.com. That is spelled DonMachHolz.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, August 19th, the moon is 1 day past new as darkness settles in the evening. More than likely, you won't even see the crescent moon in your western sky until the 20th of August. Over the next week, the moon will be waxing. That is, growing brighter as more of the moon is illuminated each night. The moon reaches first quarter, that's 50% illuminated, next Tuesday, August 25th. By then, it will be in the south, near the constellation Scorpius. While you are out there, take a look at Mars, which rises a couple hours after sunset or shortly after it gets dark. It is presently minus 1.6 magnitude. It will brighten by yet another magnitude by opposition on October 13th, now less than 2 months away. It will become as bright then as Jupiter is now. Will you be able to see the International Space Station this week? This week we have 5 zones depending upon your latitude. If you live north of 45 degrees north, the International Space Station will not be visible this week. So Canada, Iceland, Greenland, not this week. From 20 degrees north to 45 degrees north, it will be visible in the morning sky for at least some of the week. The further north you are, later in the week before the ISS makes an appearance. Japan and Italy, India, morning sky. Between the equator and 20 degrees north, the ISS will be in your morning sky for only the first part of the week. Then you won't see it for at least a week. Central America, get out there early this week in the morning. Between 5 degrees south and 25 degrees south, it will be in both your morning and evening sky for the whole week. Brazil, many opportunities. South of 25 degrees south, the ISS will be in your evening sky for at least part of next week. Australia, Argentina, that's you. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Imagine being able to use a telescope to photograph or image any object in the night sky, and then having that image available for you to download onto your computer. And wait, there is more. You don't need to own that telescope or even know how to operate it. And you can have cloudy weather overhead and still see the sky in real time on your computer or phone. Would you like to do that? Well, you can. There are several organizations which allow you to do this. You can find them on the internet. Use your favorite search engine to look for remote telescope rental or remote telescope imaging. One of the most popular and one that I have used for several years is called SLOOH. It is spelled SLOOH. SLOOH has 2 telescope facilities, one in the Canary Islands off the coast of Africa in the northern hemisphere, and the second in Chile in the southern hemisphere. Each clear night, the facilities with 5 telescopes in the Canary Islands and 3 instruments in Chile capture images of the night sky. And if you subscribe, you can watch them live from their observatories. SLOOH also has online star parties for members in which experts discuss the images that they are showing at the star party, and they are there to answer your questions. Now, let's say you want a photo of the latest comet, or Jupiter, or a Messier object, or the moon. As a member, you can direct the telescope to do so. You can watch live as the object is imaged and snap a picture of it. You can also snap pictures of objects that other members observe too. When you snap a photo, it is automatically sent to your SLOOH page. You can then download it to your computer or phone at any time. And if you are not available to watch it live, SLOOH will record the image and place it on your SLOOH page for you. SLOOH.com is an easy website to use, and it has a user-friendly interface. Membership with SLOOH costs $50, $100, or $300 per year. 3 levels are available, giving a variety of services. It can be reached at SLOOH.com, spelled SLOOH.com. Now for comets. The positions in right ascension and declination for all 5 comets mentioned this week are available on podcast 27, Comet Positions. All 5 comets are also shown on podcast 33, Map 1. So what is this? The fading of the comets? Comet 2P Encke is magnitude 11 in dimming. I don't plan to discuss this comet again on this visit to the inner solar system. Comet 2019 U6 Lemon is near magnitude 11, continuing to dim. Ditto for that comet. That brings us to 2 more comets. One is Comet 2017 T2 Pan-STARRS, magnitude 10.5, slowly dimming in our evening sky after putting on a reasonable show for most of the year. Comet 2020 F3 Neowise, magnitude 8, is dimming rapidly after putting on a great show in July. Comet Howell, known officially as Comet 88P Howell, is in our evening southern sky, magnitude 10, and slowly brightening. It was discovered by Ellen Howell on August 29, 1981, with a half-meter Palomar-Schmidt telescope. When it returned 6 years later, it was given the number 88, as periodic comets are numbered in the order of their first predicted return. The perihelion distance, the closest point the comet gets to the Sun, has decreased a bit over the decades and is now 1.35 astronomical units from the Sun, and that is 1.3 times the distance from the Earth to the Sun. And that occurs on September 26 of this year. At that time, the comet will be about magnitude 8 or 9. The moon will be passing by it this week, and next week the moon will be bright in our evening sky. The week after that, we'll take a closer look at Comet Howell. I would like to report on the results of an experiment that I did last month. As an amateur astronomer, for many years, I've tried a lot of strange things just to see what would happen. And this is something I tried concerning the southern Delta Aquariids meteor shower. This meteor shower has a radiant near the star Delta Aquariid, and that location, the radiant, moves about a degree a day. What I did was to look at the radiant near the time of the peak of the shower to see what I would see. Now, when we go out and watch for meteors, we usually tell you this is where the radiant is. That is, the meteors seem to be coming from that area and then spreading out in all directions. And we say, don't look at the radiant. Look off to the left, right, up or down, maybe 45 degrees from the radiant, because that's where the meteors have a longer trail, and you're likely to see quite a few. If you look just at the radiant, those meteors are coming straight toward you, so they would have a very short trail. And sometimes if one is coming exactly at you, you'll see a place light up and then dim and disappear. And that could be a meteor coming right at you, brightening and then dimming. I tried this, though, on July 29th, 2020. And I used my binocular chair with the 100 millimeter binoculars at 25 power. The field of view is 2.5 degrees. I started at 0100 and ended at 0205 Mountain Standard Time. I was looking 1 degree west of Delta Aquariids, which at that time was to be the center of the radiant. I did this experiment from here in Stargazer, Arizona. I had calm winds and a clear sky that was fairly dark. I had no disruptions during that time. And let me just say, staring through a pair of binoculars for an hour can get tiring. But I was able to do that for an hour and 5 minutes. I easily saw a 10.9 magnitude star and was probably seeing stars down to 11 to 11.3 magnitude. Once again, the field of view, 2.5 degrees, looking right at the radiant near the time of the peak of the meteor shower. So what did I see? I saw a total of 6 meteors in that 65 minutes. 3 were probably from the southern Delta Aquariids meteor shower. They had short trails. They were to the left side of the field of view, and all of them were moving down. I'd like to try this experiment again with not just this meteor shower, but maybe others. But next time I think I'll try perhaps 7 by 50 binoculars. This would give me a larger field of view, and I would still be able to see down to magnitude 9 to 9.5. This week we're going to learn a new constellation. When you have been looking at the night sky these last few weeks, you might have noticed a small diamond or parallelogram in the sky below the constellation Cygnus. This is part of the constellation Delphinus, the dolphin. It is made up of those 4 stars in the diamond and 1 more star south of the diamond. You will find it labeled on podcast 33, map 1, and map 2. Get to know Delphinus. It's a wonderful little group of stars. Once you see it, you'll never be able to unsee it. This pod is a dolphin named Delphinus, hiding in the Milky Way due to its shyness. Near the star Altair, one of the brightest, up in the sky where there is no virus. This week we're going to observe a globular star cluster, M15. It's known as the Great Pegasus Cluster. It's plotted on podcast 33, map 2. This globular star cluster is 30,000 light years away. The magnitude is about 6.3, and under good conditions, you can see it with the unaided eye. It measures 18 arc minutes across, and it is filled with stars, about 100,000 stars. The age of the cluster is estimated to be 12 billion years old. It's one of the earliest clusters known. Through binoculars, it appears as a fuzzy ball. You will not see the individual stars in it. M15 through the telescope does not appear symmetrical. It does not have uniform brightness. Look for some of the dark patches seen by other observers through the ages. Also see if you can pick out some of the individual stars near the edges. You have been listening to Looking Up with Don, podcast episode 33 for August 19th, 2020. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DonMACHHOLZ.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss what's going on in the sky. We will continue observations of the comets, and I'll talk about an epic study done on visual comet discoveries written in 1967. Thank you for listening. See the sky this week. I'll see you next week.